Our eighth program is to find the minimum cost spanning tree of a given connected undirected graph using Kruskal's algorithm, and we have to use the union find algorithm in our program. Okay, so let's discuss what the program is, and before that, the link I have put in the description box for Kruskal's algorithms working, so make sure you watch that before moving on with this explanation. Okay, so let's see what the program is. See here in Kruskal's algorithm, how we'll be approaching the problem is, this is the same graph which I have explained in the video also down in the link. So let's see what the graph is and how to create this adjacency matrix. See here, between before all, there are 7 nodes here, 1, 2, 3, 4, 5, 6 and 7, and there is an edge between these nodes which is having the weight also. So between 1 and 6 the weight is 10. So in this matrix what I have done is, between 1 and 6 I have written 10 here. The same will be true for 6 and 1 also, because it's undirected, right? So between 6 and 1 also there will be 10 only. Okay, like that for all the edges I have written. For 1 and 2, 1 and 2 it is 28, and for 2 to 1, 2 to 1 is also 28. Okay, like that I have filled all the cells in the matrix, and the same number cells will have 0. Okay, means from 1 to 1 there is no edge, so I will be writing here 0, and same for 2 2, 3 3 and till 7 7. Okay, and after that the empty spaces which you can see here are the empty spaces which don't have any nodes here. Okay, means 1 to 7, see here 1 to 7 there is no node here. 1 to 3, 1 to 3 also there is no connection, so I will be writing there empty. Actually it should be 999. Okay, means 999 or infinite, but if I write that it will become very confusing. So keep in mind here, wherever you see empty space it is 999. Okay, now after that we'll be moving on with the program, and I'll be explaining you from the main void main function. See here, this is our class kruskal, which is till here, and we have 3 functions. The first one is the find function. Okay, this is the first function, find function. Okay, and this is the second one, which is union, and the third function is minimum spanning tree. Okay, this is the third function, which is minimum spanning tree. Okay, and finally we have the void main function. Okay, so in the we'll be starting from void main function. Firstly we'll be creating a kruskal, okay, new kruskal. That's nothing but the object of this class only. Okay, so it doesn't matter if you don't understand what is this, just focus on the remaining code. This we are creating a 2D matrix of cost, which is having the size 20 20. Means this matrix we are creating, since we have only 7 nodes, I have considered 7 nodes only here. Then what we'll be doing, we'll be creating a scanner object here. Then enter the number of nodes. We'll be creating that scanner object and taking the number of nodes in n. So n will have the number of nodes. In our case n will be equal to 7. Okay, and the cost adjacency matrix will be taken through a 2D means nested for loop. Means I is equal to 1 till n, j is equal to 1 till n. I will run like this. We will be entering the values 0, then 28, then 999, then 999. Like that we will be entering for first row. Then in the second iteration, means i's value will increment to 2. Second row will be taken, then third row till 7th row it will be taken. So this matrix is ready with us. Then what's the code? The code is to call minimum spanning tree. We'll pass in the n and the adjacency matrix. So 7 and the adjacency matrix will be passed through the to the minimum spanning tree. Let's see the code here for minimum spanning tree. This is the code for minimum spanning tree, and here we'll have the initializations of the variable. For now you can ignore this. We'll moving on with the code, and gradually we'll be seeing which all variables are used here. Okay, so let's start from here. For loop, for I is equal to 1 till n, p of I is equal to I. So I've created an array here. This p of I, in all this it should have the same values. Okay, by using this for loop what we are doing, I is running from 1 to n, and i's value is getting stored at p of I. Okay, so we'll have here 1, till 7. Okay, so we have the numbers of 1 till 7 in the p array. That's done. Now what's the next code? While count is less than n. What is count? Count is initially 1 only. Okay, and n is equal to 7. Is 1 less than 7? Yes, 1 is less than 7. Means overall understand what's happening here. This while loop is there, right? This is the while loop till where it is running, till here. Okay, this is the while loop. It will run for how many nodes are there, that many times. Okay, so I'll be ignoring the count value from now. Just keep in mind that this code will be running from 1 to 7 times. Okay, 7 times we'll be repeating this code. Next, what we are doing here, we are initializing minimum as 999. So minimum value is 999, and then what we'll be doing, we'll be using a nested for loop here. In nested for loop, we'll be accessing each element. Okay, means I will run from 1 to n, means for the rows, and j will run from 1 to n, that's for the columns, and each iteration will be accessing the value of cost of ij, means this value. Okay, so in the first iteration this will be accessed, then this one will be accessed, then this one, and so on. After this gets over, it will start from here, this value will be accessed, and so on. Okay, like that we will do till the end. Okay, so what we are doing here, first we are comparing is cost of ij is equal to 0 or not. If it's equal to 0, we will be not considering that. Okay, it's not equal to 0, then only we will consider, like this one. Okay, so that's the first thing. So in the first iteration this will not be considered. Then in the second iteration, I is 1 and j is 2, means j will increment, right? In the inner loop, j will increment first. So j's value is 2 and i's value is 1, which will give 28. Okay, cost of ij. Is it less than minimum? What was minimum? Minimum was 999. Is 28 less than 999? Yes, it is. So what we'll be doing, we'll be entering this loop here. In this loop, what we have to initialize the minimum as the cost, means now minimum will become 28, and we'll be saving the value of I and j, which is the I and j value of the minimum element, which is 1 and 2, that will be stored in u and v. Okay, so now what u and v has, 1 and 2. Like that we will move on comparing all of this. Then at last what we will obtain is, we will be obtaining the least value here 10, and here also we will be obtaining 10, but only this will be considered because at that time what is the minimum value it will be assigned, here it will be assigned as 10. Then when we come to this point, the condition is 10 should be less than 10. This will not take place, that means this code will not run. If this code doesn't run, that means u and v value will be same as that of this one. What is that? 1 and 6. Okay, so u is 1 and v is 6. Now after getting the value of u and v, we will be storing here 1 and 6. Alright, we got the u and v values. What's the next code? In the next code, if minimum is equal to 999, it's not 999, it's 10 here, so we'll be not breaking, but instead we'll be calling find function 2 times. Okay, in the first we'll be passing u here, and second we'll be passing v here. Let's see what the find function does. In the find function, see here in the find function, u will be passed here and p will be passed here. So u will become v, means see this is the value, it will not take this value. Okay, see here, if I am passing here as find u comma p, u will be passed on and stored in the variable v. Okay, so this is a new variable, this is not this one. Okay, this another v will be created, and in that u's value will be stored. What is the u's value? U's value is 1. So in this case v will have here 1, this v. Okay, the v of this function. Then what we will be comparing is, while p of v is not equal to v, what is v? V we passed here as 1, right? So what is the value of 1? P of 1 is 1. So v and p of v both are same. So we will not consider this while loop. Instead we will return v. Returning v means returning the same value which we passed. Okay, so I will be returned. So 1 will be returned. Where it will be returned? On I. See here, 1 will be returned from this function, and that will be stored in I. So let's make that change here. The return value is 1, so I will be storing here 1. Alright. Then what's the next thing? Same thing for j also. For j I will be passing v. V means 6 I will be passing. 6 will be passed to this function, and here 6, p of 6 and 6 will be compared. What is p of 6? P of 6 is 6. Is both equal? Yes, both are equal, so this will not run. Okay, then we will return v. V means 6 only, so 6 will be returned to j. Okay, so now j has 6. Okay, now I and j value we got. Then what we have to do is, we will be comparing I and j value. Then if I is not equal to j, is I equal to j? No, I is 1 and j is 6. Okay, so when it's not equal, we will be performing this line of code. What is in this line of code? In this line of code, we will be storing the value of u and v in another variable. Okay, means just assume that this is another 2D array. I am not going into this because it will make things complicated. Just keep in mind that u and v value is getting stored somewhere. Okay, so that means since we have selected this element, 10 corresponds to which one? 1 and 6. That means we have selected which node here? 1 and 6 is selected, right? So what I will be doing is, in a part of code I will be storing u and v value. So 1 and 6 will be stored somewhere. Okay, this is in another 2D array. Okay, this we have 1 and 6 here. Then what we'll be doing, we'll be finally storing all the nodes which we select, and after that we will be printing each node one by one. Okay, so for that purpose only we are storing here the edge here 1 and 6. Okay, so let's see further what we can do. That is for t of k, t k of 1 and t k of 2. In that u and v will be stored, and then k plus plus and count plus plus. K is also same thing as count, because in k also what we do, k also is kept for keeping the count, means k will start from 1, it will also keep the count only, means how many edges we have selected. Okay, in first k will be 1, so one edge is selected, first edge is selected. K will be 2, in second index that edge selected will be written. K will be 3, in the third index the third edge will be written. Okay, for that purpose only we have used this variable k. Okay, so for now I will be ignoring the k and count, this is just for keeping how many edges have been selected. Okay, then we will be calculating the sum plus is equal to minimum. This is nothing but we are calculating the cost of this 10 that will be stored in sum. Okay, because since we are whatever edge we select, that sum should be calculated. So for that I will be whatever edge we select, that sum should be calculated, right? So for that I will be keeping the sum in a separate variable. Okay, and then finally what we do is, this is the most important part, union ij, I comma j comma p. So I, which is 1, and j, which is 6, and p, these three things will be passed on to the union function. In the union function it will be seen if I is less than j, then p of j is equal to I, else p of I is equal to j. What is the I and j value? I is 1 and j is 6. Which is high, which is low? This is high and this is low. So what we do is, in p of j we will store I. P of j means p of higher variable, means see here what we are basically doing is, we will be finding out the two in this edge what is the two nodes 6 and 1. In 6 and 1 which is high and which is low? 6 is high and 1 is low. So in the p of high we will be storing the low value. That means in p of 6 we will be storing the low value which is 1. So when we get an edge here and two nodes, we will be finding out the higher one, and in that p, means p of 6 will be storing the lower one. Okay, here I will be storing 1. So that means high is connected to low, means p of 6 is this one, means in 6 means 6 is connected to 1. In that format we are storing. Okay, that we will get to know why we are particularly choosing this format in the upcoming code. Okay, now here I will be storing 1. Okay, then after doing that, what's the code? That was for the first iteration. Okay, then we will make cost of uv and cost of vu as 999. So this code here will become 999. That means it's not to be considered. Okay, you can think it as this one. Okay, it is not to be considered. 10 and this one also. Okay, cost of uv and cost of vu both will become 999. That means it's same as the empty spaces here. Then what we will be doing is, we will be repeating the same thing for the second time now. In second time also we will be starting from the while loop here. See here, this while loop got ended at this point, but still count is less than n, because only one time we have performed, and count is incremented here. So now count is 2. We have to perform till 7, right? So for that we will be taking minimum value as 999 now. The minimum value will be 999. Then we will be performing the same thing. We will be finding out the minimum among this adjacency matrix, means the next minimum we are finding out. The next minimum is 12 here, right? So we will be selecting 12 here. The I and j value is 3 and 4. So for u and v it will be stored as 3 and 4. So let's edit that value here. For 3 it will be this one, for u it will be 3, and for v it will be 4. So let's write the value here. 3 and 4 is stored. Next, what is the thing which we need to do? We need to see if minimum is equal to 999. It's not. So find of u comma p and find of v comma p. These both will be passed. What it will check is, firstly we will be passing 3. So is p of 3 equal to 3? P of 3 is 3? Yes, it is. So we have to return v, not executing this line of code. We will return v. What is v? 3. So 3 will be returned and stored in I. See, I is getting returned here, right? I is equal to find of u comma p. So this returned as 3. Then we will be storing here 3. Okay. So here I will have 3, right? And j will also have the same, because p of 4 will be passed and it will be checked p of 4 is equal to 4 or not. It is same, so 4 will be returned and we will be storing here 4. Okay, so here 3 will be stored and here 4 will be stored. Next, what we need to do? One thing I will do, I will erase this one since it's same as 999 here. so it will not cause confusion. Okay, now what's the next thing? After getting the I and j value, we'll be comparing if I and j are same or not. It's not same, so if it's not same, what we should do? This thing. That means we'll be noting down the u and v value somewhere in the memory, means the second edge which we selected. The least edge is this one, then the second least edge is this one. So we have selected 10 and 12. That means 4 and 3 is stored somewhere in the memory, okay, in the T array. And k plus plus count plus plus sum is equal to sum plus minimum, then union of ij, means I and j value will be passed, 3 and 4 will be passed, and in union what we do is we'll find out the greater one. In 3 and 4, which is greater? 4. So p of 4 will become the least one, which is 3. So here I will be storing as 3. Alright. Now 4 has 3 here, 3 will be remaining same only one of them we have to edit, okay, based on which one is greater. That was for the second iteration, and we'll make the cost of uv and cost of vu as 999. Okay, so let's make that change here. This will also become 999. After that, what we have to do is we have to go for the third iteration. This one is over 10, then 12. Again we will perform the nested for loop and find out the least minimum, which is 14 in this case. 14 corresponds to 2 and 7, so u's value is 2 and v's value is 7, and then we will be passing the same thing to the find function. See here, 2 and 7, we will be finding out if it's same or not. P of 2 is same as 2, yes, so it will be here it will come as 2, and p of 7 is same as 7, so here also it will come as 7, right? So now what's the value of I and j? I will be 2 and j will be 7, right? So I is 2 and j is 7. Now I and j both are equal or not? It's not equal. If it's not equal, we will save this edge somewhere in the array, in the 2D array, means 2 and 7 edge will be saved, 2 and 7 edge will be saved, and then we will do k plus plus, count plus plus, and sum plus is equal to minimum. Then we will do union of ij. What does union do? It will find out the greater one among this, means 7 is greater, so we will store in p of 7 as 2. Okay, so here it will be stored as 2. After storing 2, what we should do? We should make the cost adjacency matrix as 999. So let's make 2, 7 and 7, 2 as 999. Okay, these both will become 999. Again we will do the same thing, find out the minimum. Minimum is this one, 16. So in 16, 3 and 2 will be there. So 3 and 2 will be passed here, and when let's write down here 3 and 2. The new vertices are 3 and 2, sorry, 2 and 3. 2 and 3 will be in the u and v. Then what we will doing, we will finding out I and j. How we will do that? We will check if this is same. If 2 and 2 is same, we will pass on the same value. If 3 of 3 is same, we will pass on the 3 value. Then we will see if I and j are same or not. It's not same. That means we have to store this edge in some place in the memory. So in 2D array, 2 and 3 will be saved, and after that, when this is saved, then we will do the same thing, which is k plus plus, count plus plus, and sum also we will calculate, and then union of ij and p. Union, what it will do? It will see if which is higher one among this. 3 is higher, so p of 3 should have 2. So here I will be writing 2. All right. So sorry, here I will be writing 2. We have written here 2. Then we'll be making the cost adjacency matrix of. Then we will be making the change in the matrix. This is the edge which we have selected with 16. So this will also become 999. And after this becomes 999, the next one we will find out the minimum, which we find here as 18, corresponding to 4, I as 4 and j as 7. So that change we will be making here. First it will be stored in u and v. So u and v value will become 4 and 7. Then we will be finding out I and j. Is p of 4 as 4? No, it's not. If p of 4 is not same as this, then what's the case? Till now we are getting the same thing, but now the thing is changed. P of 4 is not same as 4. So here p of 4 is v is 4 here. P of 4 is not same as 4. If it's not same, then what we will do is p of v's value will be sent to v. What is p of v's value? P of v is p of 4, which is 3. So now v will become 3. Okay. So now when v is 3, then what we have to do, again do the same loop. Now v is 3. Let's note it down somewhere. This is another v, okay. Here the value of v is 3 now. Then v is 3, so again we will do the same thing. We will check p of v value is not equal to v or not. What is p of v? P of v means this one. This is also not same. If it's not same, v will become p of v value. V is 2 now. P of v is see, v is 3. P of 3 means 2, so v should be 2 now. So here I will be making the change as here I will be making the change as 2. All right. So here v is 2 now. What's the next thing? We will check again p of v is not equal to v or not. P of v means p of 2. This both is same. That means this is the selected element. Then we will be returning that element in I. Okay. I will be having this value 2. Okay. Same thing we will do for 7 also. This is not same. This means what we have to do, if it's not same, we will go to that location. V will become this. Then we are again checking p of v is same or not. It's same, so this value will be returned. So here also it is 2. Okay. So when this value has been returned I and j, then what's the next step? See here, when we have got the value of I and j, we will be checking if I is not equal to j. Is I equal to j? Yes, I is equal to j, so we will not perform this line of code and make the cost efficiency matrix as 999. So why we did like this? Now understand which all rows were selected. See here, I will be marking with different color. This one was selected, right? See, this one was selected 1 and 6. Okay. Then we selected this one 3 and 4. Then we selected 7 and 2. Then what we selected 2 and 3. Now it's our time. We are selecting 7 and 4. If we select 7 and 4, what will happen? This will form a cycle, right? In Kruskal's algorithm, it's not possible to form a cycle. Okay, that will be the wrong answer. So we can't do this. How we will know that we should not do this? What we will be doing for that is 7 is connected to 2, right? So that for that only we stored this value. 7 is connected to 2 and 2 is connected to what? 2 is the least element among 7 and 2, so 2 will not be connected to any further least element. If it had been connected to other least element like 1, but this edge is not selected, so it's not registered till now. Okay, so when this will be selected, then 2 will be writing here as 1. Okay, at that time the least one among these connections are 1, but in our case the least one among these connections are 7 and 2 is 2. So 2 is the least one, so that value we returned here. Okay, coming to 4, 4 is connected to 3, the selected edges I am talking about. 4 is connected to 3, so in 4 3 was written. Okay, 3 was minimum, but 3 also has a connection with other nodes. 3 is connected to 2, so in 3 and 2 which is the least? 2, so we have written here 2. Then again we will compare 2, which is the 2 is connected to, 2 is only connected to 2, right? So because there is no other edge which is selected till now, so in the 2 value we will have only 2. Okay, so what we do is, if we select these both vertices, means these both nodes, if we select, at that time what will be the total connections minimum node? Okay, see the total connections are this one and this one. In all of this we have 4 vertices, 7, 2, 3 and 4. In this what we will see is what is the minimum node among all of these 4 vertices. If the minimum node among all of these 4 vertices is same, at that time we can say that these all nodes are connected. Then only we can see that the same minimum one, then only we will get the same minimum value, right? If these both are not connected, suppose that here only black was there, okay, suppose that this was not there. Okay, if this was not there, at that time what value we have got? The minimum among this connection is 2 and minimum among this connection is 3, different value we get. But since it's connected, we will finally reach to the same value only. So this indicates that if we connect this one, it will form a cycle. Therefore we should not connect it. For that what we will do, we will see I and j value. If it's giving us the same minimum value, we should not perform this line of code. That is given by, if I is not equal to j, means the minimum value is not same. At that time only we should perform this line of code. If it's same, make the cost efficiency matrix as 999 and continue with the further code. Okay, so that's what we did here. Now we'll be making the cost adjacency matrix as 999 in this place and this place. Okay, so here we have done with this. Then we'll find out the next minimum, which is the next minimum node. In this we get 22. 22 is 4 and 5. So what we do is we will check for 4 and 5. For 4 it is 3. 3 is connected to 2. So here 2 will be returned. And for 5 what is the case? For 5 phi, it's phi only, because phi has not come into the selection till now. Phi has not been selected till now, so phi will be 5 only. So in the value of phi, it will be phi only. Then what we will do is, since I and j value are not same, see here, we got here phi, right? We got here phi, so the j value also which was written is phi. These both are not same. Which is the higher one? 5. So in the 5 place I have to put the lower one, which is 2. So here I will be writing 2. Okay, here I will be writing 2. Then I will be finding this one, means k plus plus, count plus plus, and sum also I will calculate. Then union. What does union do? Union we have already done here. Then I will be erasing the node from the adjacency matrix. Okay, means that node will become 999. Okay, so this one and this one will become 999. And which node we have selected? This one, right? 4 and 5. So this is selected now. The next one is among these three, which is the minimum one. See here, among 28, 24 and 25. 28, 24 and 25, the minimum one is this one. It corresponds to 5 and 7. Let's see for 5 and 7. For 5 it is 2, for 2 it is 2. So for here I will get as 2. For 5 I will be getting the j value as 2. I will be writing here 2. Okay. Then for 7 I will be getting 2. For 2 also it is 2. So here also I will get as 2. For 7 also I will get as 2. Okay, since I got the same value for 7 and 5, that means if I form this edge, which is 24, if I form this edge, a cycle can happen. See here, if I form this edge, what will be the selected vertices? 5, 7, 2, 3 and 4. The minimum one among this path is 2, and from this path is also 2. So therefore I can form a cycle here. So cycle should not form, therefore I will be ignoring this vertex from here. Okay, so which is 24, I will be not considering. Okay. Then the next minimum is 25. It corresponds to 5. It corresponds to 5 and 6. So 5 and 6 will be checked here. 5 is having 2, so here I will get as 2. For 5 I will get as 2. What is the case for 6? For 6 I have 1. So for 1 also it is 1 only. Okay, so I will get two distinct values here. That means for 6 I will get as 1, and for this I will get as 2. When I get distinct values, what I have to do is, I have to see if I is equal to j or not. It's not equal, which is higher value? 2 is higher value, so what I should do, in 2 I have to write the lower value, which is 1. So here also I will get as 1, right? So here I will get as 1, then I will be forming this edge here. Now I have formed the edge here. At that time, till this time, count will become 7, because see here, count started from 1, 1, then 2, 3, 4, 5, 6. Then if I again if I try to do, it will become 7, and it will become equal to n. N is 7, right? When count will become equal to n, which is 7, at that time this will not execute. Okay, this line of code will not execute. At that time, what's the case? If count equal to n, means yeah, count is 7. That means we have selected all the vertices here. So finally the kruskal's graph will look like this. This is the final graph which we obtained from kruskal's algorithm, and this is the minimum spanning tree. Okay, means among all the edges, the selection of these edges gives the minimum cost. Okay, that's the main aim of the kruskal's algorithm. Now I was telling, right, we have k of 1, k of 2 and all, which we are saving here, means in the k value, that is for the output purpose. Okay, in the output we will get as follows. See here, this is the output which you get. If I type this same adjacency matrix, if I type this same adjacency matrix here, at that time I will get the output as this one. Okay, see here, this is not the output, this I made for custom purpose, but the actual output is this one. Okay, the minimum spanning tree cost is 99, which is the sum of all of these edges. If you add all of these edges, you will get 99, and the spanning tree is shown below. See, 1 and 6 was selected first, so 1 and 6 is stored. I had told you, right, I am storing this somewhere in the memory, that is in the T2D array. That will be printed here. 1 and 6 will be printed. The next one was 3 and 4. 3 and 4 is printed. Then 2 and 7, this is printed, and this one and then this one, then this one, then this one, finally 6 and 5. Okay, this is printed. So this is all what you have to do in this program. Let's move on to the next one.